No. So you are attending .NET. Okay, now started up, completed. No. C Sharp, ASP.NET. No. Okay. Okay then. Then see, like this course includes the mainly two languages. Hello, online students, can you hear me? Okay, okay then. No. So this course includes two languages. One is SQL, another one TSQL. So when this is completed, your course is completed. Okay, then. So learning SQL Server means so learning these two languages. Then okay. Now so then, but before going to this, we'll have some what discussion about what is this SQL Server. So where we use, how it is useful to you. Then, sir, using .NET, what you develop applications, web applications mainly, desktop plus web. Okay, then. So that applications are actually divided into three parts. Okay, now that application is divided into three parts. So in any application, in all the applications, okay, you develop applications to input the data. Yes. So suppose, for example, I'm going to one website. So this is one website. In this, create account, create account. Then, so it is asking what's it? See, I want to create account like Gmail account like that. So it is asking your email, password, retype the password, country, name, job title, phone number, company name, address, city, state, like this. Yes. Okay. Then, so using this, you input the data. Okay. So then tell me what is this is called? Hmm? What is this is called? Form. This is called form. Then, so what is this is called? This is called form. Okay. Then, so you can say this is form, or you can say UI, or you can say what? Front end. Okay, now then. So you can say form, you can say UI, or you can say front end. By using this form, UI, front end, you input the data. You input the data, input the data. How these front ends are created? These front ends are created by using HTML, CSS, JavaScript, next, Angular, next one, React. Okay, then. So using these technologies, you create these front ends. And using this front end, you input the data, but whatever the details you enter, these details are stored permanently or not? Yes. This company will store customer details. So they store the customer details. Then these details are stored in one place. What that place is called? Database. What that place is called? Database. Or you can say what? Backend. Using front end, you input the data. Using backend, you store the data. How these backends are created? That means how databases are created. So databases are created by using some technologies. One is SQL Server. Next one, Oracle. Next, MySQL. Next, PostgreSQL, MongoDB. Okay, then. So these are the technologies. By using these technologies, you create database. These are the technologies. By using these technologies, you create front ends. Okay, then. So can you connect this HTML form to database? Huh? Can you connect this HTML form to database? No. HTML form can be connected to database? No. HTML form cannot be connected to database. Okay, then. So what you need some, okay, na? Then you need one more between these two. So what this is called? This is called middleware. So this HTML form is connected to this middleware. This middleware is connected to this one. You can't directly connect HTML form to database. You connect the HTML form to this middleware, and this middleware is connected to this one, database. Understood? No. So, like, what are the middlewares? One is WhatsApp, .NET. Another one, WhatsApp, like what? Java. Next one, Python. Okay. Next, Node.js. So what are these? All these are examples for middleware. So HTML form is connected to .NET. .NET is connected to SQL Server. HTML form is connected to Java. Java is connected to Oracle. HTML form is connected to what's it? Python. Python is connected to MySQL. Understood? Then. So what is this whole thing is called? Okay, this whole thing is called. This whole thing is called full stack application. What this whole thing is? Full stack. What that includes? That full stack application contains three modules: a front end, a back end, and a middleware. So if you know these three, you can become full stack developer. If you know these three, you can become full stack developer. Okay, then. So now, but in this, what is my part is my role is this. Okay. So from this class, what you'll be learning? You'll be learning what's that? SQL Server. So in full stack development, what is the role of SQL Server? Backend. What is the role of SQL Server? Backend role. In full stack development, what is the role of HTML? Front end. The role of .NET is middleware. Okay, then. Now, sir, before going to this, then before going to the actual SQL Server, okay, then so we'll see, like we'll just spend some 1 or 2 days for database fundamentals. Once this is completed, then I'll start SQL Server. Even if you know this, maybe you know database fundamentals. Even if you know, because in your graduation degree, maybe if it is if subject is there, DBMS subject is there in your, so maybe you learn this. Okay, then. So even if you know this, just take it as a revision then. So what is database is? What is database? Okay, what is database is? A database is a what? Organized collection of what? Interrelated data. Okay, na? What is database is? Database is a organized collection of interrelated data. So in this, there are two terms. I'm using the two terms. One is organized, another one what? Interrelated. Okay, what is this interrelated means? For example, then if you take what? For example, bank database. A bank database stores what? A bank database stores what? Data related to what? Customers, data related to what? Accounts, data related to transactions, data related to loans taken by customer, data related to employees. Okay, then what is this is? This is interrelated. Customers is related to accounts, accounts is related to transactions, accounts is related to loans like this. So this is interrelated. Next one. Next, you take university. Sir, every university maintains what? Database. Suppose what is stored in university database? They store the details about what? University, what sir? Colleges. They store the details about courses offered by university. They store the details about what? Students join. Next one, they store the details about faculty like this. What are these? All these are interrelated. Okay. College is related to courses, courses related to students, faculty, teachers, courses to the student. So these are interrelated. That's why every database stores what? Interrelated data. A bank database doesn't store data related to. A bank database doesn't store data related to university students. A university database doesn't store data related to bank transactions. Okay, na? That's why every database stores interrelated. Plus also it is what? Organized. Not only storing the data is important, the data must be what? Organized. Okay, then. So like you take example, library. Suppose engineering college library. All books are in one rack. Computer science, electronics, electrical, mechanical, all books are in one rack. If all books are in one rack, what the problem is? The problem is finding the particular book is difficult, time taking. Okay, na? If you keep separate racks, one rack for computers, one rack for electronics, one rack for electrical. If you keep separate racks, then finding the book is what? Easy. So similarly, in database also, not only storing the data is important, the data is what? Organized. Okay, then. But in database, how the data is organized? In database, the data organized by using what, sir? Tables. They use one structure. What is the structure they use? Tables for storing the data. Okay, na? You know, table means rows and columns. Then, so customer data stored in one table, and accounts data stored in one table, transactions data stored in one table, loans data stored in one table, employees data stored in one table. The data stored in separate tables. What is the advantage? Finding the data is easy. So customer, you want to find the customer address. You want to know the customer address. To know the customer address, you don't need to set the entire database. You don't need to set the entire database. Go to the customer table. Go to the customer table, find the customer address. Okay, then. So you ask for statement. You go to bank, you ask for statement. If you ask for statement, they don't need to set entire database. They go to transactions table. So get the statement and give the statement to the customer. Okay, na? Understood then. So setting is what, sir? Easy. If they store data in separate tables. Okay, then. So now, for example, a bank database stores data related to customers, accounts, transactions, and loans, etc. And a university database stores data related to, okay, students, courses, faculty, etc. Okay, then like this. Okay, now next. Okay, now then next. Sir, actually, what are the different ways we can store the data? Oh, database is one. So tell me, what are the different ways we can store the data? We can store data in what, sir? Variables. We can store data in files. We can store data in databases. So we can store data in variables. We can store the data in files. We can store the data in databases. So then data stored in variables is what? Not permanent, not what, sir? Secure. The data stored in files is what? Hmm? Permanent and not secure. The data stored in database is what's that? Permanent and also secure. That means, okay, na? Suppose if any company wants to store data permanently, if they want to provide security to the customer data, compulsory they use database. Understood? If any company wants to store the data permanently and they want to provide security to the customer data, so compulsory they use what? Databases. Okay, then. So now, and one more thing, sir, database means don't think that something else. Okay, then. So database is permanent storage or temporary storage? Permanent storage. What is the permanent storage in your laptop? Hmm? Oh. What is the permanent storage in your laptop? Hard disk. So suppose then see this hard disk size is 100 GB. This hard disk size is what's it? 100 GB. In 100 GB, then in 100 GB, I'll take what's it? 25 GB. Hard disk size is 100 GB. In 100 GB, I'll take what's it? 25 GB. Create what's it? Database. In 100 GB, I'll take 25 GB. Create what's it? Database. Okay, now then. So what the difference is? The difference is this is public memory. This is private memory. This is what? What this is? This is public memory. And this is what, sir? Private memory. Why this is called public? Because once you log into Windows, you can open C drive, D drive like this. But once you log into Windows, can you access database? No. So I want to access Oracle database. I want to access Oracle database. Then what it is asking? It is asking what's the username and password. So without giving the username and password, can you access the database? No. Okay, then suppose I'm giving some ABC XYZ username password. Then so it is saying invalid username. Understood, na? Then so without username password, you can't access what? Database. I want to access SQL Server database. To access SQL Server database, then what it is asking? Login and password. That means, so this is secured or not? So this memory is secured or not? Yes. Sir, database is also permanent storage, but secure. Okay, na? And one second, it is managed by this memory. This memory is managed by hmm? This memory. This memory is managed by OS, operating system. This memory is managed by this memory. This memory is managed by a software called DBMS. Understood? So this is managed by OS, operating system, but this is managed by a software called DBMS, database management system. Understood? Then, no. So then, plus, and one more thing, okay. Earlier, companies used only one database, but nowadays companies are using two databases. Every company uses what's that? Two databases. So types of what? Databases. One is OLTP, another one, what's that? OLAP. So nowadays every company uses two databases. One is OLTP, another one OLAP. What is OLTP stands for? Okay, na? OLTP stands for. OLTP stands for what's it? Online transaction processing. Online transaction processing. What is OLAP stands for? Online analytical processing. OLTP stands for online transaction processing. OLAP stands for online analytical processing. Nowadays, every company uses two databases. Okay. What for first one? What for second one? The first one is for storing day-to-day transactions. The first one is used for storing day-to-day transactions. Okay. Then, like suppose bank, you take bank maintains OLTP. What is stored in OLTP is like you go to ATM, you do money withdrawal. When you do money withdrawal, where it is stored? When customer go to ATM and do money withdrawal, where it is stored? It is stored in bank OLTP database. Okay, then so you use PhonePe. Using PhonePe, you do money transfer. So where it is stored? It is stored in what's that? OLTP. So every transaction is recorded in what? OLTP. Amazon maintains OLTP. You go to Amazon, you place order to buy the product. Immediately the details are stored in Amazon OLTP database. When you purchase the product, immediately the details are stored in OLTP database. So every transactions are recorded in what's that? OLTP. Airtel maintain this OLTP. You take a SIM card, you like make a phone call, that is stored in OLTP. You recharge, the details are stored in OLTP. So every transaction is recorded. Okay, then. And what for second one? Okay, now see, Amazon also uses OLAP. What for? To analyze the data. What for? To analyze. So this is used for data analysis. This is for storing day-to-day transactions. This is for analysis. Okay, now if company wants to analyze the data, they use OLAP. Amazon want to analyze the last 5 years data. They want to analyze the sales. Okay, then they use OLAP. This is for analysis. And we cannot do the analysis by using OLTP. Okay, na? Because what is required for analysis? If you want to analyze, what is required? Hmm? Huh? Oh, yes. If you want to analyze what is required is history is required. What is required? History. Like who is the best player in cricket? Can you decide from last match? Yesterday match? Can you decide? No. If you know past 5, 10 matches, then you can decide who is the best player. Understood? That means what is required for analysis? Historical data is required. But what is this OLTP stores? Current data. It will not store history. You understood? Okay, na? Then, sir, here, like suppose, then they are storing customer data, customer ID, customer name, customer address. Customer ID, suppose 10, name some name, his address is HYD. Okay, they store current. What is this HYD? Current address of the customer. Okay, na? From OLTP, what we can provide? We can provide only current data. But sir, 2020, what is the address of the customer means? You cannot. 2015, what is the address of the customer means? You cannot answer from OLTP. You can give only present address, but past address, 2020, what is the address? 2015, what is the address? Means you cannot. Because see, this customer is shifted from HYD to Bangalore. What they do? They change this HYD to Bangalore. That means what you will be losing? Sir, this customer is actually HYD. He shifted from HYD to Bangalore. Then what they do? They change this HYD to Bangalore. That means you'll be losing the old address or not? Yes. Understood? Then, but what this database stores? This database stores current data plus also historical data. From this database, you can tell current address plus old address. So 2020, what is the address of the customer means? You can answer to that question from OLAP. 2015, what is the address of the customer means? You can answer from OLAP. Sir, okay now? That no. So then, see, organizations what uses OLTP for storing day-to-day transactions and OLAP for analysis. Okay, then. So next, or you can say OLTP is for what's that? Running business, and OLAP is for to analyze what's that? Business. One is for running the business, another one is to analyze the business. Okay, then next. Okay, now what are the like day-to-day operations? Next. Okay, now what are the day-to-day operations? Sir, actually, one second. Okay, and see, actually, so these are the applications. These are the what's it? Applications. What applications? If you take bank, one is ATM application. One is net banking. One is WhatsApp, mobile UPI. Okay, now then. So what are these banking applications? Then this application generates what's the data. You go to ATM, you do the transaction, some data is generated or not. You use net banking, do the money transfer, some data is generated. Using UPI, you do some transaction, some data generated. So all these applications generates what's the data. Whatever data generated by these applications, the data stored in what's the one database. What is the database is? OLTP database. Okay, na? So application generate the data generated by application stored in OLTP database. But the data stored in OLTP is not suitable for analysis. Why? Because it stores only present data. But for analysis, what is required? History is required. That's why what they do, like they introduced one more database. What is the database? OLAP. OLAP database. Okay, na? Then, sir, here, what is the source for this data? What is the source for this database? That means for this database, what is the source? Source means the data comes from where? What is the source? Applications. What is the source? Application. Data comes from applications. What is the source for this? OLTP. For this source is applications. For this source is OLTP. That means what they do every day, they copy the data from what's the OLTP to OLAP. Okay, na? The process is called ETL process. The process is called ETL process. By using this ETL process, they copy every day, copy the data from OLTP to OLAP. Once data is copied to OLAP, then next what they do what's that? Analysis. So they analyze the data. Okay, then next. So then suppose here what's okay now? What is this is analysis. Then this is what's it? What is this is pie chart. Okay, then next suppose for example then okay then so this is what's the line. Okay now then that's all. This is end to end where the data is generated, where the data is analyzed. So then now so tell me here see then how these applications are developed. Okay now how these applications are developed. Hmm? How these applications are developed by using .NET, Java, Python, okay na, HTML, CSS, JavaScript, like this. By combination of these technologies, you develop the application. How database is maintained? How this database is maintained? By using SQL Server. Okay na? Then so these applications are developed by using these technologies, and how OLTP database is created by using SQL Server. How OLAP database is created by using SQL Server, or you can use Oracle, anything. Okay, na? Whether it is OLTP or OLAP, you can use SQL Server. How this analysis is, how these graph charts are created by using some technologies. One is Power BI, another one Tableau. Otherwise, you can also use Python. Okay, then understood. Then so this is what like what are the technologies used to develop these applications. So applications are developed by using .NET Java. So OLTP database is created by using SQL Server. OLAP also you can use SQL Server, and this is created by using what's it then. Not only SQL Server, you can use what you can use Oracle. You can use what's it PostgreSQL, like this. Here also you can use what Oracle, or you can use PostgreSQL like this. Understood that? Now, so next, sir, here one student is learning .NET. So if student is learning .NET, he want to be part of this development. He'll be part of this development. A student is learning Power BI, then he part of this development. Understood? One student is learning Java, .NET, etc. Then he is part of this OLTP development. A student is learning what's it? Power BI, Tableau, Python, then is part of this development, OLAP development. Okay, then. Okay, then. But What are the day-to-day operations on database? What are the day-to-day operations? One is C R U D. What is C stands for? Create. What is R stands for? Read. What is U stands for? Update. What is D stands for? Delete. Create, read, update, delete. Create the data, read the data, update the data, delete the data. Create the data, read the data, update the data, delete the data. Okay, now any database you take. So these are the day-to-day operations on database. Create, read, update, and what's it? Delete. So then, and one more thing. Okay, suppose one more thing. Then see, you can't directly what's it? Then suppose user, then user can't directly work with what databases. So this is the database. You can't directly work with the database. This is not possible. You can't go to the database, update the data. You can't go to the database, delete the data. You don't directly work with what database. You need a software. So what that software is? That software is what's that? DBMS. What is that software? DBMS. Then. So you want to work with the database, you give request to what? DBMS. You want to update, you give request to DBMS. DBMS will go to database, update the data. You want to delete the data, you give request to DBMS. DBMS will go to database and delete the data. That means anything you want to work with the database, give request to DBMS. Understood na? Then. So next, one more is there. What is that is? DBMS. DBMS. Then. So what is DBMS is? DBMS is what's that? Database what? Management system. Okay, database management system. What this is? Using DBMS, like with the help of what's that? DBMS, users can work with what? What? Database. Means using DBMS, users can create. Okay, na? Users can create what? Next, read, next one, update, next one, delete data in what? Databases. Okay, you don't directly work with the database, you work with the database through DBMS. Then you can say, so DBMS is an what? Interface between user and database. Understood? You don't directly work with the database. To work with the database, you take the help of a software. What that software is? DBMS. Okay, now then. Now. Next. And here, see, like we have different types of what's it? Here we have different types of databases. Similarly, there are different types of what? DBMS. What are the different types? Evolution of DBMS. Okay, na? Evolution of DBMS. What is evolution means? Evolution means step-by-step development. What is evolution means? Step-by-step development. So what is the step-by-step development in DBMS? That means in the beginning, what systems are used? Next what, next what, next what, like this. Okay, then. So now, suppose in 1960s, what? The companies used what's it? FMS. Then that means in 1960s only companies started storing the data in computers. Before that, they stored the data in books. Now they started computers in 1960. They started computers for storing the data. What the first system they were used is FMS. 70s, what's it? DBMS. What the first DBMS? HDBMS. What the next one is? NDBMS. 1980s, what? RDBMS. 1990s, what? RDBMS. So initially they started what's it? FMS, next one, HDBMS, next one, NDBMS, next one, RDBMS. What is FMS stands for? File Management System. What is HDBMS stands for? HDBMS stands for Hierarchical DBMS. What is NDBMS stands for? What? Network DBMS. What is RDBMS stands for? Relational DBMS. What is ORDBMS stands for? Object Relational DBMS. Okay, now then File Management System, HDBMS, NDBMS, RDBMS, ORDBMS. Okay, then. But these are outdated. They're outdated. No one using. Not outdated now. They're outdated some years back. So no company is using this. No company is using this. Nowadays, every company uses what? RDBMS and ORDBMS. So companies use these systems. For your course also, you need only these two, RDBMS and ORDBMS. So okay now? Then. So we need only these two. Okay, then. Now. So, but what is the difference between one to another is, okay, now? The way you store the data is different. Way you organize the data is different. Okay, then. So if you take, for example, then if you take, suppose, HDBMS. In HDBMS, they store like this. In HDBMS, they organize the data like this. So something like this. What is this is? Hierarchy. Okay, then suppose in NDBMS, they organize the data like this. Nodes, network. Okay, now in NDBMS, they organize the data like this. Now, suppose like this. In RDBMS, they organize the data like this. Tables, rows and columns. Rows and columns. Sir, okay? Then. But sir, like this is what, sir, compared to this one, this is simple structure. Table is what? Simple structure. When structure is simple, working with the database is also simple. So here in this, you want to access the data stored here. You cannot directly go to this. You have to start from here. Root node. You have to start from here, go to this one, go to this one. You cannot directly point to this one. You want to access the data stored here. So you cannot directly go to this one. You have to start from here. Take the address of next node. Take the address of next node. Then reach to the destination. So you have to like this. So data accessing is slow. But when it comes to RDBMS, directly can access the data. Okay, then. So compared to the systems, RDBMS is what? Simple to use. Okay, then. That is the reason most of the companies started using what's it? RDBMS. And even if they are already using FMS, they migrated to what? RDBMS. If they're already using HDBMS and DBMS, they migrated to what's it? RDBMS. Okay, then. So we'll discuss this in the next class. I just want to give some brief introduction. Then, and tomorrow 5:30. Okay, na? 5:30. 5:30 class. Hmm? 4 to 6. Okay, I'll make them to 4 to 5:30. Hmm? Okay. Yes, yes. Okay, now? Then. Huh? Okay, so we'll continue this tomorrow. 5:30. Hmm? Then. Because my house is far from this. So that is why, okay, then. Notes will give it like they create. I'll ask them to create Google Class, then I'll upload the notes. See, this course takes 1.5 month, 1.5 to 2 months maximum. Okay, then. So any doubts, online students? See, SQL Server, with SQL Server, Mohan, with SQL Server, like you can target the roles in .NET. Regular timings, Vijay Kumar, 5:30 to 6:30, 5:30. Okay, then. I'll share the syllabus. I'll share the syllabus. Everything I'll share it. Okay, then. Yes. Sudhakar Reddy, yes. See, time is this 5:30 to 6:30, but fee, you ask them, you ask admins. Okay, then. This is MS SQL only, Deepak. This is same course. Whatever the course you are expecting, the same course, MS SQL. Okay, then. Okay, then. You attend first two classes, then definitely all your doubts gets clear. Okay, then. SSRS is separate. This is SQL Server is separate. SSRS is separate. That is reporting service. This is day one. Yes, Vasudeva. This is day one. Okay. Same link. Same link. Link remains same. Same link. Using the same link, you join tomorrow also. Okay. Then. Okay then. No difference. MS SQL, SQL Server same. Okay, na? Then. Okay. I'll give the content, course content. Okay, guys. Okay, guys. Bye. See you tomorrow. See you tomorrow. Bye.